Good morning and welcome back to Relief Tutorials. In the previous sessions we have seen that pH value of the solution determines the strength of acidicity or basicity of the solution. If pH value of any one of the solution is 7, the solution is neutral. As the pH value decreases, means as the concentration of H3O plus ion increases, acidicity increases. So pH value is less than 7 means the solution is acidic. pH value more than 7, the solution is having alkaline nature or basic nature. Now the topic is about importance of pH in our day-to-day life. Importance of pH in everyday life. The first point is plants and animals are pH sensitive, including human beings. Plants and animals are pH sensitive. See, most of the metabolism activity in our body occurs in the pH range of 7 to 7.8. So if you see this range, pH value 7 means neutral and pH value 7.8 is nearly neutral but slightly towards basic. Okay, so we remain healthy, animals particularly remain healthy if our body solutions having pH nearly 7 to 7.8. Okay, even plants also remains comfortable, also grows easily, healthily between the near about range of pH. Have you heard about acid rain? It's an effect of pollution of air. Acid rain means the rainwater, if having the pH nearly 5.6 or less than 5.6, acid rain, the water which contains pH value less than 5.6. So I think you can see that value of pH is less than 7 and nearly less than 6 also. So if the pH value is less than 5.6, such type of water is having acidic nature and such type of rain is called as acid rain. And if such type of water flows into the river, it lowers the pH of that river body also, that pond, lake, whatever, and it affects the aquatic life. The plants cannot grow fluently, aquatic animals cannot survive in such type of water having the pH value less than 5.6. So, which is the safe range for our metabolic activities is 7 to 7.8. In short, plants and animals, including human beings, are sensitive to pH. Second point, pH in soil, in garden, in our backyard. We grow some plants. So we require healthy pH range, and that pH range is nearly 6.5 to 7.3 nearly. So this range of pH of soil is a healthy range. So in such type of soil, plants can grow easily and healthily. So for the better growing of plants in our agricultural land or backyard or garden, we required pH of the soil should be between 6.5 to 7.3. So I think it's nearly about to neutral. If our soil is having pH less than this, means less than 6.5, so it means the soil is acidic. So we have to add, if soil is acidic, then we can add fertilizers which are basic in nature. And if our soil is more basic, if I say the value of pH in our soil is more than 7.3, more than 7.3 means nearly 8 or 9. So that type of soil is basic and which is also not comfortable for the growing of plants. So we can decrease the basicity by adding the acidic fertilizer. So whenever we are trying to grow something in our garden or agricultural land, any type of crop we are trying to grow, first of all we should know the pH of the soil. That can be done in the soil examination centers. So once we know the pH of the soil, we can add corresponding fertilizers to maintain the pH range of the soil between 6.5 to 7.3. In short, soil is also pH sensitive, and corresponding to the pH of the soil, growing of plants can be decided. Third, pH in our digestive system. So we know that to digest our food, stomach walls secrete particular type of acid for the digestion of food. We know that is the acid secreted by stomach wall is dilute hydrochloric acid. Okay, many times you have felt that if you eat something spicy or oily in some marriage function or the parties, so there is some particular type of burning sensation you can feel in the chest region, and that is nothing but the extra amount of HCl is secreted to dilute that type of complex food. Because the more complex food you eat, more HCl has to be secreted by the stomach walls to digest them. So excess amount of dilute HCl is secreted by the stomach walls, and that creates some burning pain or burning sensation in the chest region that we called acidity. Okay, so the region of this digestive part means stomach, food pipe, that region having acidity means what, that region having pH value less than 7. And that is not comfortable for our body, so we have to neutralize it. So our chest region, food pipe and stomach having acidity means acidic nature, so we have to eat or we have to drink such type of liquid which is basic in nature. Normally we drink what? Milk. If you have a little amount of burning pain or burning sensation, if you feel something like acidity, then you can first try milk to neutralize that region, because milk is basic in nature. And still if you are not comfortable, then I think you know about ENO, which is available in the market. So this ENO is nothing but the basic baking soda. Baking soda is a basic substance. Formula is NaHCO3. Sodium bicarbonate is the basic in nature. So ENO is made up of baking soda, and that is basic in nature. I think you have seen the advertisement in the TV that in 6 seconds, in just 6 seconds, ENO removes acidity. The simple reason is that why it is acting in 6 seconds only, because your stomach region is acidic in nature, and what you are adding basic sodium carbonate, which is basic in nature. So what they do, when baking soda enters in your stomach region, it reacts with the acid and neutralize the region. And once the stomach region or the food pipe region becomes neutral, there will be no acidity left. And if you have extreme acidity, then one more substance is very famous in the market, that is milk of magnesia. Milk of magnesia, formula for that is magnesium hydroxide MgOH twice. Doctors recommend this milk of magnesia to remove the acidity because it is quite basic in nature. So when it adds to your body, it neutralizes the acidic substance present in your body and gives relief to your acidity. Next topic, next fourth, pH change. In our mouth leads to tooth decay. pH change in our mouth leads to tooth decay. See, our teeth have a particular layer on it, and that layer is of calcium phosphate. That is called as enamel, means one of the layer of calcium phosphate. It's one type of covering over teeth that it cannot be decayed easily. Whatever the way you rub your teeth by any type of brush or toothpaste, whatever, calcium phosphate layer cannot be removed easily, and that provides the strength to our teeth. But this calcium phosphate layer can be corroded by acidic natured substance. Calcium phosphate having the formula Ca3PO4 twice. This layer is present on your teeth. This layer of calcium phosphate cannot be easily. So this enamel cannot be easily get corroded by any other substance, but this can be easily corroded by acidic natured substances. Now what happens when we eat something? So the food particles remains there between the gaps of the teeth for a long time if we don't wash our mouth clearly after having some food. So that food particle which left between the gaps of teeth, the bacterial activity start decaying that food particles and they release some acidic substance, and that decreases the overall pH. Because the acidic substance releases, that decreases the overall pH of our mouth. And as the pH of our mouth decreases, the acidic natured substances starts decaying this calcium phosphate layer, and it starts decaying of tooth also. Many times we have seen that our elderly people present in our home, I think their teeth decayed and become blackened. Because a black teeth becomes because of what? The layer of calcium phosphate is decayed by the acidic natured substance present in our mouth. So what we can do to prevent this type of decay? So first thing, the habit to be developed, that we have to wash our mouth clearly with the clean water. Okay, after every meal, after every food we eat, we have to wash. See, we cannot brush every time because number of times during the whole day we are eating something here and there during 9 to 10 times. So we cannot brush up our teeth every time, but we have to wash our mouth clearly. And one more habit, you have to brush your teeth before sleeping at night. That is a good habit, because if food particles left during the whole night between the gap of the teeth, it will have more time to decay, it will have more time to corrode the layer of this calcium phosphate. So be careful and develop such type of habits. Is that clear? So what we have to do, we have to clean our mouth, and the toothpaste which we use is basic in nature, so that will help to decrease the acidic nature of the mouth. It neutralizes the mouth pH and decaying of tooth can be prevented. Okay. Fifth, we see that self-defense by animals and plants, by chemical warfare. See, I think you have felt sometimes the red ant. Have you felt the bite of red ant? Honeybee. This type of insects, when bite us, they inject formic acid in our body. Formic acid, the chemical formula for this acid is HCOOH. When red ant, honeybee, such type of many insects, when bite us, they inject formic acid in our body, and it creates the particular type of pain and irritation and swallowing in that particular region. So what we can do to prevent that type of pain and sensation? We have to use baking soda. Baking soda is the easily available substance in our home stuff. Okay, so if you just use that mild base, this is a mild base, over that particular injected area, you will get relief from that burning sensation or pain. So these red ant, honeybee and such type of insects defend themselves by such type of acid injecting in the opposite animal. So they protect themselves by this type of chemical warfare. Even plants. Have you heard about nettle leaves? The photograph is given in your textbook. Please look at that. Nettle leaves having particular type of aged leaves. So when any insect or even human being are walking, and if you just got the cut by these nettle leaves, you will again feel some irritation and burning pain, because that nettle leaves also inject formic acid in your body. Formic acid, the other name of formic acid is methanoic acid. See, whatever the name you get in your textbook, both are same. So they inject this formic acid in your body, and again that can be easily prevented by applying baking soda on that cut. Okay, so this is all about importance of pH in our regular life. This is the quite important and easy topic as compared to the examination point of view. Now the topic is changed. Up to here we have seen about acid, base and their characteristics and their definitions, how to identify the strength of acidity with the help of pH and etc. And now we are moving towards salt. What is salt? We know that if the solution liberates H plus ion, that is acid. If the solution liberates OH minus ion in its aqueous solution, that is base. But what about salt? So salt is normally obtained by neutralization reaction of acid and base. So indirectly, listen to me carefully, indirectly we can say that salt is a product obtained by neutralization reaction of acid and base. So when any acid reacts with base, they form salt and water. This reaction is called as neutralization reaction. So salt is nothing but the byproduct of reaction of acid and base. So every salt, for example, NaCl is one of the salt. So this salt is obtained by some of the reaction of acid and base. So by observing this salt carefully, we can derive its acid and base. Na corresponding base is NaOH and Cl corresponding acid is HCl. So we can say that NaCl is a product of two parental acid and base. Okay, so NaCl, the salt, having its parents acid and base are NaOH and HCl. So remember from this discussion that every salt having its parental acid and base. If I say CaCl2 is one of the salt, first of all, how can you identify that it is a salt? So try to find out whether it is any H plus ion in this. No, so it is not acid. Is there any OH minus ion present in this? No, so it is not a base. So if you are not seeing any acidic characteristics or basic characteristics, such type of all the substances are salts. Now again we can find out its parental acid and base. So observe this salt carefully. Ca is the metal, and we know the base is obtained from metal. So corresponding base, so this is metal we found, so corresponding base will be, so react this Ca with OH, so it forms CaOH twice. Calcium hydroxide is the corresponding base, and Cl, which acid contains Cl? That is HCl. H is added and OH is added. OH is added to Ca and H is added to Cl, so we will get corresponding acid and base. For example, NH4Cl, the salt, sorry, this is salt because is there any OH minus? No. Is there any H plus? No. Here NH4 is combinedly ammonium ion and Cl minus is chloride. So corresponding acid for Cl minus is HCl and corresponding base for this is NH4OH, ammonium hydroxide, the base. HCl is the acid. So every salt having its parental acid and base. Now, based on this, first of all, we have two types of acids and base. Then we will go for the types of salt. Okay, first of all, acids. Strong acid and weak acid. What do you mean by strong acid? Strong acid means the solution, the molecules of acid ionizes 100% in their aqueous solution. Means, let us say this is water. This is water, neither acidic nor basic. Now when you add 10 molecules of HCl, you have added 10 molecules of HCl. So the question is, we know that when HCl is added here, H and Cl get ionized. Here you have added 10 HCl. So the question is whether all these 10 molecules of HCl get ionized and they form 10H plus and 10 Cl minus. So if all the molecules of acid which you have added, ionizes, means if the ionization is 100%, here we have added 10 molecules of HCl, all 10 get ionized. If you add 100 molecules of HCl, all 100 will get ionized in aqueous solution. So if it is happening, if molecules of acid ionizes 100% in their aqueous solution, then such type of acids are strong acid. And what about weak acid? The molecules of acid ionizes hardly 4 to 5% in their aqueous solution. Means if it is water and if you are adding 100 molecules of one of the acid called CH3COOH, acetic acid. So you are adding 100 molecules of CH3COOH, so all 100 will not get ionized. Out of this 100, hardly 4 or 5 molecules get ionized, and remaining 95 molecules remains as it is, unionized. So only 5 will get, for example, 5 molecules get ionized, so they release 5 CH3CO minus ion and 5 H plus ion. So you think that we have added 100 molecules, it creates larger acidicity, but it is not so. Out of this 195 remains as it is, and if it remains as it is, if it is not releasing H plus ion, acidicity will be less. Because this amount of this H plus ion matters to create the acidicity, but it is not giving all 100%. Such type of acids are called as what? Weak or mild acid. Same logic we can use for the bases also. We have two types of bases, strong bases and weak base. Same logic. If molecules of base ionizes 100% in their aqueous solution, then such type of bases are strong bases. And if the molecules of base are not ionizing 100% in their aqueous solution, then such type of base are called as weak base. We have a list of strong acid, you have to remember the names. Strong acids, HCl is strong acid, HNO3 strong acid, H2SO3 sulfurous acid strong acid, H2SO4 strong acid. Means whatever the amount of this type of molecule you add in water, they will ionize 100%. So that is nothing but the strong acidic behavior. One more is H3PO4 phosphoric acid. These are nothing but the strong acids. What about the weak acids? CH3COOH is weak acid. And one more name I want to tell you is H2CO3 carbonic acid are weak acid. One more name, HCOOH formic acid. Recently we have discussed this, that it is present in the ant or honeybee sting. Some other names having no formula, citric acid, tartaric acid. We have heard these names because these acids are present in our food stuffs, tamarind, tomatoes and such type of lemons. Citric acid, tartaric acid, palmitic acid, and number of names are there. These are the edible acids. Edible acid, these are edible acid. This is not edible. These acids are present, if you remember the vinegar, acetic acid is present in vinegar which we eat with the Chinese bhel and etc. Citric acid, tartaric acid, palmitic acid, and number of other acids, fatty acid. These are the acids present in our food stuff. So these are all weak acid and these are the strong acids. Same way we have a list of base. Strong acids, NaOH, sodium hydroxide, strong base, LiOH, lithium hydroxide, NaOH strong base, LiOH strong base, KOH strong base, CaOH twice strong base. These are some strong base: sodium hydroxide, lithium hydroxide, potassium hydroxide, calcium hydroxide. Weak bases are, the very famous weak base is NH4OH, ammonium hydroxide. Magnesium hydroxide is also the mild base, milk of magnesia. Recently we have discussed this. These are some weak base. Very less names are there in the bases. You have to remember these strong acids, weak acids, strong bases, weak bases. You have to remember the names, and based on that we can decide the types of salt. Let us see the types of salt. Consider, let us see with the example, it will be very easy. Let us say NaCl. So we know that every salt having its own parental acid and base. So corresponding to Na, which base is that? NaOH. And Cl, corresponding acid is HCl. So this is strong base and HCl is what? Strong acid. We know, we have just seen the list that acid NaOH is strong base and HCl is strong acid. So the salt is neutral. This is neutral because both the acids and base are strong. So when they react, we know the reaction that NaOH plus HCl gives to NaCl plus water. This is strong base and this is strong acid. So both destroy the properties of each other and they give you the totally neutral salt. And if this salt is neutral, what about its pH? Its pH is 7. Are you getting this? This is strong base, so its pH is more than 7. This is strong acid, so its pH is less than 7. Okay, but both are strong, so both are capable of destroying the properties of each other and they react 100% and they gives you the salt which is neutral. One more example of neutral salt, let us say KCl, potassium chloride. So corresponding base for K is KOH, which is strong base, and Cl, corresponding acid is HCl, so it is strong acid. So if both are strong, the salt is neutral. So KCl is a neutral salt. If I take one more example, so if I say Na2CO3, sodium carbonate. So corresponding base for Na is NaOH and corresponding acid for CO3 is, we know that H2CO3. Recently we have made the list for that, H2CO3. But H2CO3 is a weak base, weak acid. The NaOH is strong base and weak acid. So listen to me, Na2CO3 sodium carbonate is a salt obtained by the reaction of weak acid and strong base. So here the strong base, see, this weak acid cannot destroy all the properties of strong base. So the salt becomes basic salt or alkaline salt because it contains its parent base as strong base. Acid is weak but base is strong. So because the weak acid is not capable of destroying all the properties of this strong base, the salt becomes what? Basic salt or alkaline salt. Got it or not? For example, one more, NH4Cl, ammonium chloride, the salt. Now NH4 is a positive ion, so corresponding base is NH4OH and corresponding acid for this is HCl. So NH4OH is a weak base, we know it. Okay, and HCl is a strong acid. NH4OH is weak base. Look at here. And HCl is a strong acid. So now this salt, see here, weak base is not going to destroy all the properties of this strong acid. So this NH4Cl still having some acidic characteristics. Such type of salt is acidic salt. And if this salt is acidic, its pH value is less than 7. And if the salt is basic, so its pH value is more than 7. This way, if I say one more example of salt, that CH3COONA, this is sodium acetate salt. Now corresponding to this Na, we can write its base is NaOH and corresponding to the CH3COO, its acid is CH3COOH, acetic acid. Vinegar, we say this is weak acid and NaOH is a strong base. So the salt which is obtained here having some basic characteristics, so this is basic salt. Basic salt means its pH value is more than 7. If I say one of the salt as CH3COONH4, ammonium acetate salt. Now corresponding to this CH3COO, its acid is CH3COOH, and corresponding to this NH4 base is, it is what? NH4OH. So this is weak base and here is weak acid. So here both are weak. So here again both are capable of destroying the properties of each other. So again such type of salt is neutral salt. So corresponding to the parental acid and base, there are three types of salts we have discussed. Neutral salt having pH value 7, basic salt having pH value more than 7, acidic salt having pH value less than 7. So now from now on, whenever you see any type of salt, for example KNO3, potassium nitrate, this is salt. Okay, now K, so corresponding to K, the base is KOH, and corresponding to NO3, acid is HNO3. KOH is strong base, HNO3 strong acid. So both are strong, so this salt is neutral, and if the salt is neutral, its pH value is 7. So these all things which we have discussed about the types of salt and strong and weak acids and base, these all things are not given in your textbook. So please prepare these notes. This is quite informative and it will be very useful in the further part of the chapter also, and also in future 11th, 12th science also. Please make the notes. Be practicing. Best of luck.